Okay, so for this version, I'm seeing a vertical asymptote at x equals 3. And then I see this hole in the graph. And we talked a little bit about that with the notes. But so what happens when I have a hole in the graph? Here, let's make a little graph here. Let's get going with this. So I know the vertical asymptote's at x equals negative x equals 3, and it's positive. And it doesn't act like 1 over x squared. It acts like 1 over x. So I know I don't have to square that. And then I see the hole in the graph. So that tells me that x equals negative 2 is not in the domain of this function, but there's not a vertical asymptote. See, I know 3 is in the domain of this function because there's a vertical asymptote there, and the graph doesn't cross. There's no point on this graph that has 3 as a x coordinate. So 3 is not in the domain. But also negative 2 isn't either. And the way you get the graph, a function to have a hole in it, is you're going to put the same factor in the top and in the bottom. And this is kind of where we start in calculus next year, next semester. Is you have the same factor top and bottom, because you could cancel those off and then you would just be in some version of some number over x of x minus 3, but because of the hole in the graph, we got to make sure we eliminate it at x equals negative 2. So then I see, what else do I see? What are they at? I've never done this problem before. Let's see. So I know the hole is at x equals negative 2. And the vertical asymptote is x equals 3. Oh, so they're telling me there's no leading coefficient. So all they're asking us here is, so actually I'm done. I don't have to do any more work with this. They're saying that they aren't worrying about any kind of stretch factor. So all I got to do is put in, let's see, it has a hole at x equals negative 2. It has a vertical asymptote at x equals 3. So that tells me B, notice how B is the common factor. So B is going to be the 2, negative 2, I think they probably want. And A will be the 3. Let's see how I do. Oh, bazinga, there we go. Okay, so that's how you deal with that. So learn that the hole, where the holes happen, you got to put the same factor in the numerator and the denominator. Okay, so hopefully that will help you do this question.